the gain of the third loop will be, the feedback loop will be, it will be, the gain will be, it will, it is G5 into minus H2 into minus H1. So finally that is nothing but G5 H1 H2. So that is what we have written here also. So the gain of the third feedback loop will be G5. It is going like this and coming back with two feedback back, mm, two feedback, it is coming back to the same point to x1. So it is G5 H1 H2. So now coming to the next one, that is, it is called the self loop. We had one more self loop here. If you look at this diagram, there was a self loop and the gain of the self loop will be H3. The gain of the self loop will be H3. Either it is minus or plus depending upon whatever is written. We take the gain to be H3. If it is minus H3, it will be minus H3. Non-touching loop. This is very important concept. Non-touching loop. Two loops. Loop means with that is which starts from one point and comes back to the same point is a loop. So we already saw there is three loop. So here all these loops are touching. That is, this and these two loops are touching. Here the anyway the third and first is also touching. That is, the nodes are common. Touching here means it will have a common node. Whereas if I am looking at this circuit here, suppose I am looking at this circuit for this this signal flow, these two loops are not touching each other. This is between, suppose I mark the nodes here. This is, say this will be node 1, say this is node 2, say this is node 3, and say this is node 4. None of the nodes are common between these two. Whereas in the above case, the nodes were common. Here the nodes are not common. This is 1, 2, back to 1, 3, 4, back to 3. Where in in the above case, the nodes were common. They had common nodes. Here they don't have common nodes. They are non-touching loops. Next, coming to Mason's formula, very important formula, the Mason's formula. In the Mason's formula, this is the one which will be used to find the transfer function. The transfer function T of S, which is equal to C of S by R of S, is given as summation Pk delta K by K. Delta, sorry, Pk delta K by delta from K 0 to 1, where K, it represents the number of forward path. K represents the number of forward path. In the whatever example we saw, there was two forward path. So K value will be 2. The path gain of K forward path. How many forward path we had? Two forward path. We had in this case, if we see, we had two forward path, isn't it? G1, G2, G3, G4. Then it was G5, G3, G4. So we had two forward path. The gain again would be G1, G2, G3, G4. And for the second one, G5, G3 and G4. That is the gain of the forward path. P represents the gain of the forward path. How many hour we have? If we have two gains, we will have to write. Delta. Delta is equal to 1 minus summation all the individual feedback loop gain including self loop. All the individual, that is individually how many feedback loops you have, how many feedback loops, all those gains. Suppose there are three feedback gains, that is the feedback gain of the first loop plus feedback gain of the second loop plus the feedback loop of the third loop, and if there is a self loop, the feedback gain of the self loop as well, plus all the product gain of non-touching. As we saw here, product gain. What is a gain? Product gain. Here we are talking about the product gain. Okay, that was not that what we were seeing in the transfer block diagram. G divided by 1 plus or minus Hg was the uh, total gain. Here we are just seeing the product gain. Here we are seeing the product gain. Product gain would be here G into H1 minus H1, G3 into minus H3. Non-touching loop. These two L1 and L2. L1 and L2 are loops and they are also non-touching. So product of the non-touching loop plus all the product of three non-touching minus the product of three non-touching loop plus the product of four non-touching loop. It goes on like this. And delta K will be delta calculated for the forward path. This is delta for the entire this one signal flow. Delta K would be the delta value for the kth forward path. That is for the first forward path and second forward path, third forward path, like that. You write down this, where you better write it down. Then later on, when we do the problem, you will come to know how to calculate. Please write this down. This equation is very important. Please write it down. And anyway, I'll be sharing the PDF also. So in that case, if you cannot write down now, write it down from the PDF. Let us go to the first problem now. Coming to the first problem, for the signal flow graph shown below, using Mason's gain formula, find the, this n should be capital, find the transfer function. Here, this is the signal flow. Please write it down. And from the Mason's formula, we saw the transfer function was pk delta k by delta summation k. Summation k. What is the first? Let us see pk. How many pk is what? P, that is the forward path. How many forward path does this signal have? How many forward path is it having? It has three. It has one. It has two. We have written the forward path also here. See, the forward path here is, it goes from when the signal flow graph is given, please mark the node so that it will be convenient for you to later on analyze. I have written the node in the red pen. 1, 2, 3, 4. In the exam, these nodes are not given. You have to mark those nodes 1, 2, 3, 4, 5, 6, 7, 8, like this. What is a forward path? 1 to 8. Straight line you have. Draw all that and write down the gains also between each node. That is between 2 and 3 it is G1, 3 and 4 it is G2, like that. So the gain of the first path will be G1, G2, G3, G4 and G5. What about the gain? Do you have a next path? Yes. See this G6 and 1. That is, it starts from RS 1 into G6 into, it comes here again into 1. So 1 into G6 into 1. So the gain will be G6 for the second path. Next, is there any other path? No, we don't have any other path. Next, loop 1. We have a loop 1 here. Let this be the first loop. What is the loop of, what is the, have written it here. What is the first loop? It is between 3, 5, 3, 4, 5. This one between 3, 4 and 5. So this will be the first loop. This is going to be the first loop here. See, this is the first loop that we have. That is from, it is from the, it is this loop 3, 4, 5. G2, G3 and minus H1 is the first loop. What about the second loop? Do we have a second loop here? Yes, see, there is a second loop here. Which is the second loop? Coming back to this, this was the first one. Which is the second one? Here, this will be the second one. This one. See, this path is the second loop. See, can you see this? It is G1, G2, G3, G4, G5 and minus H2 is the second loop. What about the third loop? Do we have a third loop? Yes, we have a third loop, that is G6 and minus H2. G6 and minus H2. It is G6, this path, and minus H2, this path. So the loop gain will be minus G6 into H2. Any non-touching loop? Is there any non-touching loop here? Do we have? This is one loop. This was L1. This was L1. Then this entire thing was L2, and this one was L3. Do we have non-touching loop? Do we have a non-touching loop? This was L3, isn't it? This was L1. L1 and L3, is it touching? L1 is inside and L2 is on the outer side. There are no common nodes between these two. So these two are the non-touching. L1 and L3 are the non-touching. So what is the product of these two? Multiply this. That is G2, G3, H1 into G6, H2 will be the product of those. That is product will be L1 and L2. So what is delta? 1 minus, if you look at this, this is 1 minus summation of all individual feedback loop gain including self loop. In this case we don't have self loop. So minus summation of, okay, my 1 minus summation of L1, L2, L3 loop gain plus 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 the plus all the product gain of two non-touching, all product gain of two non-touching, individual product gain of self loop first, then product of the two non-touching, here L1 L3. So here it will be L1 L3, as I said, multiply this as well as this value. You have to multiply this as well as you'll have to multiply these, multiplying this. So final value, delta value will be 1 plus, because here every value is minus, you take out minus, minus of minus will be plus. That is G2, G3, H1 for the first loop gain. Then G1, G2, G3, G4, G5, H2 for the second one. And this one will be the third one. Then product of L1 and L3. This is delta. What about delta 1? What would we say delta 1? It is delta 1 minus delta calculated for the kth forward path. Kth forward path means, is there any loop, non-touching loop for this path? Here there are loop, but it is touching all the forward path. It is touching all the delta here will be calculated if there is any loop which is not touching that path. We have one path here and there is no loop which is not touching. All the loops are touching this forward path. So there is no question. So it is only 1 minus 0. What about delta 2? Delta 2 is, what is delta 2? Which is the path? This is the path. Is there any loop which is not touching this? Yes. Is this loop touching? No. So what is that? Whereas this loop, if I am considering this loop or the outer loop, it touches at these two nodes. I cannot consider it. This, it is going to touch it at these 2 points. It is going to touch this. It will touch them at these 2 points. So I cannot consider the outer loop, cannot be considered. We cannot consider the outer loop. Only this, the inner loop can be considered. I can consider this inner loop. So now delta 2 will be 1 minus of minus, what is the gain of this? G2, G3 minus H1. G2, G3 minus H1 will be the delta 2. Delta K value is, PK we know it is a forward path gain. PK is forward path gain, and delta K for that would be any loop which is not touching any node. ಇಲ್ಲಿ ಯಾವ ನೋಡ್ ಅನ್ನು ಟಚ್ ಮಾಡದೇ ಇರುವಂತ ನೋಡ್ ಇದ್ರೆ that will be the delta K. ನಮ್ಮ ಫಸ್ಟ್ ಫೀಡ್ಬ್ಯಾಕ್ ಲೂಪಿಗೆ there was no loop, feedback path ಗೆ ಯಾವ ಲೂಪ್ ಸಹ ಟಚ್ ಮಾಡದೇ ಇರಲಿಲ್ಲ. Whereas for the second loop, for the second one, if you see, for the second one you see here, for the second one, if when you see, this will be the second forward path, second loop, and the second forward path was this one. This was the second forward path, and we had one